Good morning, Professor.
Good morning. Thank you.
Good morning, Professor.
Awesome. Good morning. Oh, okay. All right. Oh, things are happening. Hold on. I'm going to say hello in a second. Weird things are happening. Sorry. Hold on. Sorry. Okay. Bear with me, everybody. I'm not even looking at the screen at the moment. I will say hello in a moment. You're welcome to say hello, but hold on. Sorry. Something just happened. Okay, bear with me for, congratulations, everybody. Just bear with me for one more second. Or actually like 2 minutes, I'm sorry. Sorry, if anybody, well, yeah, just bear with me for one more. Okay. So good morning, Noelia. Good morning, Jean-Pierre. Good morning, Ashley. Good morning, Michelle. Good morning, Alyssa. Morning, Zitlali. Good morning, Amarani. Good morning, Darina. Good morning, Molly. Good morning, Yasmin. Good morning, Nikaya. It is good to see you guys. It's actually particularly good to see you because, well, like the first thing is really, and I don't want to overstate the case, but congratulations for real. Like it, oh, and good morning, Catherine. Sorry. Good morning, Catherine. I took a second, I was taking this, well, I'll explain what the delay was in a moment, but the thing is really, I know I can say this with confidence, anybody who's sitting here right now, hearing me at all, and good morning, Daniel. Sorry, good morning, Daniel. Awesome. All right, so if you're here now, that's already an accomplishment in many ways. Number two, if you're here now, and I believe I've just cross-referenced and cross-checked like 85 times, I hope I'm not insulting anybody, but yes, if you are here now, it means that either you got your exam in on time, and in some cases, some people got them in noticeably early, which is super impressive. But if you're here right now, it means your exam is in and you're sitting here, or it means that there's an exceptional case and there's a reason your exam is not in, but you made that very clear to me days ago with a text message or something. And there are a couple of like extreme cases, but anybody whose exam is not, any exam I don't have right now, I know why I don't have it. And I was, and I gave permission to that for exceptional reasons. So honestly, that means everybody has like stepped up, and it means that everybody here basically is done with something that maybe wasn't the most easy thing in the world. I don't want to dwell on this for too long, but I do want to say, like, I've done a lot of physics. I've spent a lot of years doing physics, and particularly whenever I've been in the student role, which is many, many years, it's never easy. And it's never as easy as I think it's going to be or something like that. And I'm the kind of person that once I got something in, I mean, I know you might be worried about grades. I know some of you might think that you didn't do a good exam or something, and maybe even some of you didn't do as well as you would like or something. But it is, first of all, an accomplishment to get the darn thing in and to be done with it. And everybody should breathe a sigh of relief about that. And honestly, especially in this class, or the way I like to think about things, you even if it ends up that your exam's not perfect or something like that, there's a lot still room to save yourself from any kind of imperfection now that it's in. Like the hard part is over, or at least for that exam. So again, not to dwell on it, but really, I hope that right now for most of you, your feeling is not one of, oh my God, I wonder what I got, or oh my God, I got like, oh my God, I need to get this back right now. Like I hope that you can breathe a little bit, as will I. Well, now I won't be able to read now. I have to grade them and all that. But really, well done. And also, and good morning. Sorry. And also, just to say too that in a class of this nature, with life being what it is, but also with me being the way I am, you know, I know that I'm very loose and vague about certain things, and hard to predict about certain things. So it really is very clear to me from the way that people communicated, from the way I got texts and stuff like that. It's very clear to me that you guys all knew to take this particular deadline seriously. And it's very clear to me that you're working very hard to take my instructions seriously about the exam. Like from the little that I've seen so far, it looks like people really did at least try, really give me something that wasn't just a spit back of my solutions. And that took a while to learn. And so that's all to your credit, seriously. I cannot invent grades. I cannot, if you got a lot of things wrong, I can't make it not true that you got things wrong, but I can tell you this, everybody's a human being, including the person grading your stuff. And whatever zone of ambiguity there ever is, whatever zone of borderline that anybody might ever fall on, like, should I give them 2 points, or should I take off 2 points, or should I take off 1 point for this thing? Or, oh my God, they got an 89.5. Is that a B plus or is that an A minus? Just so you know, like I'm a big believer in the tie goes to the runner, which is an expression from baseball, but like I'm a big believer in benefit of the doubt goes to you. And especially in situations like this, the more you're showing that you're actually trying to engage with the class, which is what you are doing, then the more it just makes it super easy for me whenever there's a borderline case or a borderline judgment call. I'm going to make the judgment on your side, not against you, because of things like this. Like they add up karmically or whatever. So again, obviously there's some exceptions to everything. And if you're sitting there right now feeling like dirt about what you did, I don't mean to be making you feel worse, but really it seems like on the whole, you guys did something here and should be patting yourselves on the back or relaxing about it. I will try to get them back as quickly as I can. Ideally, I would get them back to you by Monday. I will try to do that. I might not get them back by Monday because things are also complicated in my life, but I will try. Okay, I'm going to pause for one more. So now, and one other like logistical thing. I know I had that updated correction portal. Like I made a correction in the test and I updated and made another portal. And then of course that made things a little confusing about where you were supposed to turn in the test. I didn't mean to, but it did make things a little confusing. Just so you know, and I've checked, obviously I've looked, like I see that all the exams are in, and I even see that like one person even warned me that they were having technical difficulties and it was going to be really late and could I please forgive, and then they still got it in at like 10:51. Like I see all of that. But I do see that I accidentally made 2 portals and that caused confusion, and somebody even wrote me about that. So here's the deal, where I prefer the exam to be just for ease of grading is that the original portal. That's really where I'm going to look for everything and where all the numbers will be averaged and stuff. If you put your exam in the second portal, like the more recent portal, I see it. I see that it's on time, and in fact, the person coming in right now is one of those people. I'm going to hold this because this actually applies to the person coming in. Hang on one second. Okay, I'm just going to wait one beat because I know. All right, so the truth is, it's totally, some people put the exam in the more recent portal. There's no way you could have known what was in my head. I actually tried to tell Google Classroom like not to allow that. I was going to put it in the stream, whatever, but it didn't work. So if you put your exam in either portal, I saw it. I saw how early it came in. I'm talking to everybody here, but in particular, honestly, I think I'm talking to like 4 or 5 people in the room. If you put your exam in the more recent portal, I totally see it. I totally have it. I totally see that it was totally on time. Then I attempted to write a note to about 4 or 5 of you that hopefully maybe. Oh, here goes another person. Sorry. If you put your exam in the second portal, hopefully maybe you see that I wrote a comment to you. Just congratulating you and just asking you to put another copy of it in the first portal. If you, whoever you are, if you know, good morning, son. Good to see you. Good to see you. If right, so if you put your like check for a notification or a comment from me or whatever, if it says something like please put another copy in the other portal, please do that. It just will make all the grading more straightforward and organized. But I do know that it's on time. It won't be marked late. Thank you. Um, uh, uh, so you can do it by the end of this class or whatever, do it fairly soon if you can. But so the ones that I'm going to grade I'm going to grade all the ones in the original assignment portal. But if you put it in the other one, again, there's no punishment or anything like that. It would just make it easier for me if you could also put a copy in the first portal. And if you never do that, if you never get, and also, I guess I should really rush to say, I'm still confused about certain aspects of Google Classroom. So if you're one of those people that put the exam in the more recent portal, then since I tried to send you a note about that, and since I'm going to put all the numbers and the grades in the first portal, I tried to send something back to you. But if for whatever reason it looks, if on your end, if it looks like you just got your exam back and it's a 0, which is not my intention, but I didn't put a grade or anything. So if you just got it back and it suddenly looks to you like you got a 0 or something, absolutely not. That is not what I'm saying. I'm just saying that I'm not putting grades in the second portal. I'm putting them in the first. So please just make a copy of it. And maybe if one of those people who knows who they are, if one of those people knows what I'm talking about and did see the comment and gets it, if they could either send me a private chat or a public chat just saying, yeah, I got it, it's no problem. That would make me feel better, because I do not want nobody is getting a 0 here. I mean, even if your exam's not in now, you're not getting a 0. I mean, you're getting consequences, but so I just want to make that clear before we move on. Let me just look in the chat. Oh, thank you. Oh, yes. Okay. Right. Oh, yeah, right. No. And it was unclear on my part. I should have made it clear which to put in. I tried to fix that, but I couldn't. So if you put it in both, if someone, and I guess, yeah, Michelle's saying, right. All right. If you put it in both, then ignore my note. If you put in both, totally fine, great. I'm just telling everybody I'm going to grade the ones in the original portal. And it's my bad that there was any ambiguity at all. So right, if you already put in both and you've already done your job, basically my goal is like when we are done with this class, I just want to forget about the second portal, and it's not, I just want to forget about it. If you all know what I'm saying. So that's the point. Okay. All right. So any other, but again, I think you guys did well. I mean, just glancing at them, they look and honestly, they look so much better than the first exam of this class. Maybe this is the other reason I'm congratulating you all. And maybe some of you are uncomfortable with that. Like maybe, okay. Right. No, and I saw that and I totally saw that you totally did it on time. I don't know anyway, private chat person. Yes. But just if you could put another copy in the second, that would be great. But the other reason I'm like congratulating you people, which is also weird if you haven't even gotten your grades back, and I know that, but like really just glancing at these exams, the way they look impressionistically, it would be, it's very hard for me to imagine that any of you like failed it or got some disastrous grade. Like maybe some of you didn't get an A. I mean, we'll see, right? But and we'll talk about grades when they come back. I'll tell you right now, like even if you got like a 70 on this exam, or 75, even if you end up getting a 75 in this exam, that does not mean necessarily that you're not getting an A in the class. I can be more direct when I give them back to you, and I know the mean score and all that stuff, but the classic question that I always get, especially after the first exam, first course of physics, like the first thing that people tend to ask when they get their grades back is, oh my God, if I got this number, does that mean there's no way I can get an A in this class? It's always a fair concern. But I'm to tell you right now, the number has to be, even if the number is like in the 70s, it's between lab and all your homework. I mean, assuming you're doing fine in lab and assuming you're doing all your homeworks, including these game assignments. Like I'm telling you right now, just historically, you could get like a 75 on this thing, and it doesn't mean you're not getting an A or an A minus. I mean, it might mean that, and it might mean you have to rock the final. But so there's another reason I'm saying, just looking at them, they look pretty decent. And they look like you worked pretty hard. A lot of you, it looks like people really went to some lengths. And I know I got some of them at like midnight last night or like 5 a.m. this morning. Like people took you guys took it seriously, I think. And it's good for me to think that even going in before I read them, like I'll be in a good mood looking forward to them. That's to your advantage. Frankly, even those of you who didn't take it that seriously, the fact that I think this about all of you is only going to serve you well too, that I'm not going to be in a bad mood looking at them. But I just want to say in the past, like, COVID is really hard. This whole situation is like really stupid and hard to learn in. But in the past, the first exam of Physics 203, especially for all you science majors who have to also take 204 and all that kind of stuff. In the past, the first exam used to be a disaster. People would really bomb it and really get upset. And I would try to reassure them, but often I was kind of upset because it was often disastrous. I'm already just telling you guys that the way these exams look, I think they look like you're a lot stronger with what's going on than historically people are with the first exam in physics. And even with those people, things work out. So, that's why I'm saying all of this. And again, it's also because I don't know how anybody's learning anything in this environment, frankly. Like, it just blows my mind that anybody's surviving at all, learning on Zoom and all of that. So, okay. I'm going to move on in a second. I'll pause for 1 minute to gather my head. But if there's any other, like, I know a couple people just came in. If there's any, but if there's any like public concern, like any questions you want to ask about this, feel free. I'm going to pause for a second. But yeah, other than that, and there will be a final exam in the class. It will be, unless something really weird happened on that one, unless there's like rampant some form of cheating that I didn't anticipate or something, you can assume that our final exam will run the same kind of format and all of that. So now that you get, and both of our exams in Physics 204, if, Cork willing, you take that class and you'll take it with me. I can tell you the class runs, the material is harder, but the class runs the same way. So maybe that's the other thing. You've just now gotten over the sort of the primary physics hump. If you can survive that first exam, all the rest of physics at John Jay is done this way. There's no new surprises except in the material itself. I should also say, you know what? Since this is that kind of day, we have to stay with the material, and I'm going to teach stuff today. But I also did promise you, I want today to be a little bit of a breathing out, not a breathing in day. So at some point soon, I'm going to move on with the material, but it's going to be sort of lecture-y. Again, I'm noting that everybody's here. I see that everybody's here. I'm going to understand in about 20 minutes when I start rolling, I'm not going to expect major participation or I know your brains are fried, or I think your brains might be fried. I will be talking. I will be giving you material that you need. Like, there will be notes, but I will totally understand that you might be on sort of automatic pilot and just taking the notes, or maybe going back and forth. I do want to, one thing I did notice as this exam got closer, as we got closer to turning in, one thing is, the one advantage that we have with all this Zoom business is that, I am posting all the recordings of all these classes on YouTube. Some of the recordings are terrible. Sometimes like the video goes out, so, sometimes class is terrible, but everything I say here and all the notes is on YouTube. And occasionally I noticed with some of the questions I was getting right before the exam that like people might have maybe like, sometimes I got a question like, well, I missed these 2 classes, so I don't know. I do encourage you as your first line of defense to always check out a video on YouTube. That's why they're there, and you could scroll through and whatnot. And I'll say that today might be one of those days. I will understand if once I get rolling on the material, because I do have to, because we can't fall too far behind. I'll understand if people are spacing out or like making pasta while I'm doing it. Just remember, check out the video later and just get the material that way. Don't forget that that's there. It does take some effort to put those there and keep them organized. So, and you don't have to like them, but subscribing would. Oh yeah, that is the other thing I did find out in the middle is, the videos go up to YouTube a lot faster than they get linked in Classroom. Like all these like things have to happen, all this formatting and stuff. Like they get there, but then YouTube sort of won't let me link them until blah blah blah. So if you subscribe, then you find out immediately when the videos are there. And then also then my son thinks I'm cool. Okay, oh, right. Here's the other thing. This is 203. You just got through your first exam. Hopefully you're all standing and you'll continue to stand as we get to the final. The final will be during final exam period. In other words, there's no more big thing until the end of, we might have homeworks, but the final will be during final exam period, but it still will be take home and all that. It'll be due the end of final exam period. Okay. why I'm saying that is I just remembered too, I don't think we've talked in this class really about next semester much. Let me give you there could be some, I think there could be some anxiety or issues about that. Let me just tell you what I know very quickly. And again, today is this kind of day. So I'm going to say what I know about next semester but if you have any questions, especially if they're not just related to you personally, like today would be a good day to ask. So let me tell you what I know about your future, so to speak. I mean, most of you if you're in 203, probably it's because you're in a major that's requiring it and requiring you to take 204 as well. Or if you're in 203 because you want to be, then I highly encourage you to also want to take 204. Number one, 204 is offered in the summer and the fall and next spring. That didn't always used to be true, but just so you know, if you're trying to plan your schedule, 204 is offered in the summer, summer session 2, whatever that. It's offered as a 5-week. Maybe some of you have even already registered for it. I'm sorry if I'm behind. Maybe it's even too late. I don't even know, but it is a 5-week session 2 course. 5 weeks is crazy. No summer course should be 5 weeks. Like I'm totally against them. They're totally stupid, but it is what it is. Okay. So some of you, okay. So maybe this is wasting your time. Thank you, Michelle. So maybe this is well, I'll just tell you quickly that if you were considering it or you did register, just so you know, during the summer, there's a bunch of sections. You can, for whatever it's worth, I don't know what's posted, but I do always teach the lectures, all lecture sections. I don't teach the labs anymore because I don't feel like it. But so you will have me again if you're in the lecture for either one for the summer. Yes, it goes very fast. I mean, it goes faster than this. Yes, the material is harder than this, but you'll be prepared for it when you get there. And even though it goes fast because it's 5 weeks, I will also tell you, anybody who's considering, it's crazy to do science during the summer, and it's crazy to do more than one science at the same time during the summer. Like maybe you could do 2, but anybody who's trying to do 3 is like, whoa. I mean, I would also get a therapist too while you're at it, like, or something. I mean, that's like a law. I couldn't do it, but you got to do what you got to do. I understand. But if you're already, those of you who are like registering for 3 science classes this summer, please at least know that Physics 204 and some other courses like it are also offered in the fall, and they didn't used to be. So you don't necessarily have to rush that fast. But I will say, even though I think it's crazy, it goes crazy fast doing things in the summer. Yeah, I mean, all right, I'm going to say like these 5-week summer courses are very controversial. Like we all were really when the registrar first instituted them. And just to be as clear as I can about my perspective on this, it is true that if you take a summer 5-week course, if you add up every minute of class time, it does equal the same number of minutes of class time during the fall. That's why the registrar and other people think it's like justified. I mean, we meet for much longer periods during the day. We meet for like double periods during the day, and we meet like 3 days in a row rather than 2 days a week. So yes, the actual instructional time during the summer does equal the instructional time during the fall. So therefore, anybody who doesn't know anything about education assumes that means, it all works out fine in the end. It's all the same thing. Of course, that does not honor the student perspective, which is, so just to remind you, the problem with these 5-week courses is that we still have to assign the same amount of homework or the same number of exams and stuff, but you have so much less time. Like you're in school all day, like for much longer. And then you get home and then you have to do all this homework for the very next day. Like, so you have less time to do it and it's due earlier. Like what they don't realize, the registrar, is that you're rushed much more at home by these classes. Now that is true. That is a disadvantage of them, just to warn you. I will say, I believe that disadvantage occurs less with physics than with the other classes, simply because I'm too ADHD or I'm too bad with, like, I just can't go that fast. I just can't go. I kind of believe that proportionally the physics is still a little bit relaxed compared to some others. I'm not saying that's good or bad, but I'm saying as much as I get scared by these summer courses, I think physics is not among the worst to take during the summer. Like sort of, and I get more chill in a way because it's the summer and I have less going on. So, you know, if you're considering taking in the summer, there's something to be said for that. Again, I'm teaching it either way, whether it's the summer or the fall, whether that's good or bad for you. Like, I don't know, but I can rest assured it's me either way, summer or fall. Summer, I think, is hard, but it's not as hard as other classes like biochem or something, which is like I couldn't take to save my life. Okay, wait, I'm looking at the chat. Okay, no, cool. Oh, and there too, of course, I'm glad Michelle just said that, and I'm glad that Ashley and Michelle, wait, is that the same Michelle? Yeah, the Michelle and Ashley, it's really good that they said that too, because I'm sitting here just trying to give you my perspective. But if there's one thing I know is the student perspective is much more meaningful than mine. Like, of course, you should first and foremost talk to your colleagues and what they've experienced and get the real story from them. So I should really shut up. But the other thing, though, as far as register, the one thing I do know that you might not know or whatever that I do have to tell you is whether you're taking it in the fall or, I mean, whether you're taking it in the summer or the fall, I can tell you for good or for bad, it's going to continue to be Zoom remote learning either way. In fact, in the fall, I don't even know if I'm allowed to say this, but the unofficial, unpublished stat for John Jay regarding the fall now, I mean, even the fall, in the fall, 90% of John Jay classes are still remote online for good or for bad. I mean, 10% or not, and hopefully you have some, and I know this is terrible for labs, it's just terrible all around. But, you know, I'm not, if you already know for a fact that you're already like looking into the fall and you already know that your instrumental class or something has found a way to be in the building, that may well be true because the priority is going to like severe lab classes with professors who are severely, you know, invested in making sure that they stay in the lab. I can tell you right now that physics is not in that category. We feel that we can survive, like our labs, they don't translate well to simulations, but they translate better than other classes do. We know that. So for good or for bad, I can tell you that physics is remaining online remote through the summer and through the fall. And that's true of 90% of John Jay, but definitely physics, whether you're taking it with me or not, whoever you're taking physics with, if it's at John Jay, it's remote through the fall at a minimum. So if you want to get an apartment in Hawaii, like go for it or whatever. Again, I'm not saying this is good or bad, but I'm just saying it's the fact. And I'm not allowed to speak about anything officially about the school, but I can tell you as the coordinator of the physics program, physics is remote and online through December. And that's whether or not you've been vaccinated or whatever. Like I'm not going in the building, and I am vaccinated. It's not a personal thing, but like, okay. So just so if you're making decisions, that's, oh, and also last thing, if you've taken this class, I mean, you know, I guess if some of you have already registered for the summer, that's good because that tells me that there hasn't been a block on your registration. That's good. That used to sometimes happen in the past. Like they wouldn't even let people register until they saw a grade from this class, which is stupid. But if you haven't had that problem, that's good. If any of you has a math prerequisite problem, but you're already in this class and doing fine, just talk. Like if you get blocked for registration because you haven't finished Calc 2 or something, talk to me. We can probably work it out, especially if I know you and you're doing okay in this class. I mean, for example, if some of you are planning on taking Calc 2 or whatever you call it, Math 242 at the same time as Physics 2, I think technically you're not allowed, but I can be very okay with that if I already know who you are and you're already doing a good job. And if you talk to me personally, and I can write a letter of consent that should work that out. So don't let that stop you either, whether it's fall or summer. If there's any other kind of advising or registration questions or anything, this wouldn't, if they're private, you know, send me a text and we'll work it out. But if it's public, this would not be a horrible time to bring them up because I know advising is like advising is hard anyway at John Jay, and it's like terribly impossible during Zoom. So this is an okay time. Let me say, okay. Oh, good question, Michelle. I believe, okay, so registration, I believe it is not, I believe registration, yes, was open for the summer, but I believe registration is not yet open for the fall. In fact, that's why I'm kind of right now thinking I might be giving some of you meaningful information. I do not think registration is open for the fall yet. And I am pretty sure that John Jay is putting some effort into not publicly committing to any firm position on online or stuff like that. So that's why I'm sort of, no, it still is not time to register for fall. But if you're making decisions, like if you're trying to decide whether to take something summer or fall, or you're wondering, like some of you might very rationally be thinking, well, I know for a fact it's going to be online during the summer because like CUNY First already says that, but I don't know, maybe it won't be online during the fall. So maybe I'll wait during the fall so I could do this for real, or like something like that. I'm just telling you, unfortunately, no, yes, registration is not open for the fall, but I'm telling you right now, the situation is not going to change for physics. Whenever registration opens, it's going to be remote, whatever you call this business. It's going to be electronic, not in person. And that's a fact that I don't think is publicly released. So that's why I'm telling everybody. But no, I think it is too early to register for the fall. I'm just trying to help make decisions. Wait. Okay, no summer there at the same time, but one day. Oh, wait, this is very good. What cat? Wait. Oh, there's a lot in the chat here. Let me just catch up. This looks like good stuff in the chat. Hold on a second. Oh, okay. Oh, good. Actually, what Melissa Coffer wrote here, that she registered for Calc 2 in this physics class at the same time with no problem. That's actually really funny. I'm thrilled to hear that because it's going to save me a lot of trouble. Because like, yes, I don't have a problem with you guys doing that. I think technically you weren't supposed to be allowed to do this. So like part of me wants to be mad almost, but no, good, fine. I mean, but then I don't want to. So good, fine. And I also will warn you guys, look, I mean, I'm talking a lot here. Things do ramp up. Like I spend a lot of times on fundamentals because I really believe the more you know your fundamentals, the more you can ramp up. Like the goal here is for me to get you guys smarter and smarter at physics so that as you get farther, you can do more of it on your own and move faster on your own. I will warn everybody, physics 2 does go faster than this. And physics 2, the calculus is very, very big part of it. It really does involve calculus. I'm not trying to scare anybody. And I never, ever actually go into that class believing that anybody actually knows the calculus that they're technically supposed to know. Like, no, we kind of end up learning it in that class. I'm very sympathetic to that. But definitely if you feel like this class, like you were forced to take calculus, but you don't even see why it was that big of a deal and where the calculus was, I get that. People often have that reaction. Like they were forced to know calculus and then they really didn't need to know that much calculus to do this. That's like true, I guess, but it's not true in physics 2. Physics 2 is very mathematical. It's more mathematical than this, just to like be clear. So in fact, in some ways, if you're taking Calc 2 at the same time as this, it's almost good for the brain to be like talking to itself that way. But when you, okay, so at the same time, no problem. Okay. And then looking, was there summer? No, for this? And wait. No, wait. Okay, I'm slightly misunderstanding. Okay, so what Melissa's saying is that she registered for Calc 2 in this class at the same time. Yes, that's okay. But if anybody gives you any trouble registering for Physics 204 and Calc 2, even there, I'm willing to accommodate, but you may need, so don't be scared away, but you may need to talk to me. But okay. Yeah, look, last thing about calculus, last thing, and I don't want to get, I'm not trying to scare anybody away. One thing I love about Physics 204 is it is very heavily calculus involved, but honestly, the reason that I'm loose about the this is a whole other subject, but if someone ever brings me a transfer student, okay, and they say this transfer student wants to transfer in, we don't know, like we only have their background on paper, but like, we don't know them, but they want to come into your physics class and like they don't have all the calculus. The first thing they're always like, can they compensate with this geometry, or like, can they take a calculus course with a tutor or something? My first question is always like, all right, let me see their transcript. I don't care if they haven't had calculus. Let me just see if they've ever taken a foreign language or a musical instrument. And if I look at them, they're like, yeah, they know English and Chinese, or they know English and piano or something, I'm like, they'll be fine. And what I'm saying with that, the truth is I hated calculus too. I hated calculus. I hated it. I didn't understand. I didn't even know what I was hating. I just knew I hated it. Now I do love it, but I love it because I learned calculus through physics. This whole idea that calculus is a prereq for physics is totally backwards as far as I'm concerned. Physics could just as easily be a prerequisite for calculus. They do speak to each other for sure, but it's not like if you don't learn one exactly at the right time, the axe is going to fall and then you can't learn the other. And furthermore, most people end up coming into Physics 204 even if they think they know calculus, first of all, they don't. They know how to do it, but they don't know what it means. And second of all, they mostly usually do hate it coming in. I'm not surprised by that at all. I hate it. Part of my secret goal in Physics 204 is to actually get people a second chance with calculus and get them not only better at it, but to see why it's worth liking. That's actually, so if you tell me you hate calculus, I'm certainly not offended and I'm certainly not surprised. I do take it as a personal challenge that like, I'm going to try to get you to like it. And so just keep your mind open that it might be that you hate it because you might not have had a great experience with it yet, or blah, or you had to go too fast with it, or blah, blah, blah. But yeah, no, most people hate it by the time they come here. Okay. Blah, 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 blah. All right. Any other things like this? Okay. Oh. Yeah. What if you've had calculus in your background by the time you come to me for Physics 204? It's good if you've had it in your background, so at least you know what the words mean, or I mean, not even that. If you've heard the terms and you kind of are familiar with what it's about and familiar with some of the operations, which is what they tend to emphasize in math class, like if you know how to do certain things, that bridges some of our communication gap next semester. But truly, most people come in knowing how to do certain things and having no idea when to do them or what they mean or why they're interesting or why they're useful. And that's what I try to do in physics. So if you could just keep an open mind, and I mean, if you're having a hard time with it now, again, I am completely sympathetic. It doesn't, and we might, both you and I, whoever you are, might even have the same taste regarding the world. But just keep an open mind that there might be something there that just went too fast for you to see or wasn't emphasized. And we will, I don't assume people get it. I assume that people have been exposed to it. And I usually assume that they've been exposed to it in a way that makes them bitter, for what it's worth. Okay, I'm gonna look in the chat one more time. And then, okay, cool, right, no, right. And by the way, I'm saying all this, like this is on tape, right? I know some of your math professors and I love them as people and as professors. Like this is not a disparagement against your calculus professors at John Jay, like definitely not. I mean, very specifically, I've worked with some, if the shoe were on the other foot, we would still have the same problem. They have a job, which is to teach you how to use the tools and to teach you how to use a lot of them and to get you to learn a lot of them fast. That's not always a fun, but that teaching people a bunch of tools doesn't make them always love like cabinet making or carpentry. Like it's just, there's not time for you to stand back and see the big picture when it's emphasized like that. I get the luxury of being able to look at the big picture and just pick the tools that work for us here in physics. I mean, so it's a luxury. It's not that they're doing it, I have, and whatever, but yeah, I hated it too, to a certain point. And I was totally scared. And when I say I hated it, I mean, I was also really bad at it. Like I never, integrals, like what? I hated integral, but now it took me a long time, but I do like them now. And I'm sure partly I like them just because I conquered the beast and it's always fun. Everybody assumes it's always easier to like things that you're better at. But what people forget, and so of course people don't like things that they're not feeling that they're good at. But what people forget is that the ultimate thing that's like really likable is when you're not good at something at first and then you work it out and you actually get good at. Then that makes you love it even more than things that you're already naturally good at, because you really feel like the investment and the relationship and the growth. Like that's that's who I am with this stuff. None of this stuff came naturally to me. I shouldn't, that's an exaggeration, but really, you're catching me at all of you are catching me at, I've been doing this again for longer than you've been alive. What you all know right now, what you do in science and math really is far more advanced and far more impressive than anything I was doing at your age. I guarantee you that. And you're better students than I was. Anything I know now is because I've been doing it for so long and because I have to talk about it publicly every day. So if I get it wrong, it's humiliating. And that's what's fear has motivated me through most of the years, fear of humiliation. Otherwise, most of you would be like, you're much more advanced than I am. You just not older. Okay. All right. So speaking of that, again, you can continue to interrupt. I'm going to kind of shift to the new material now. And still, again, anybody who said anything, like, please submit the game. You'll get 50 points for even saying good morning, or what the little kibitzing that people were just doing about calculus totally counts as class participation, totally. So I'm going to shift now to some physics. It's going to be sort of note-taking stuff. It's like a new chapter. it may be dry. I mean, I hope it's not dry, but again, if your brain is fried, I will not be insulted if you're walking in and out, blah, blah, but just please get the note and I'll give you the notes afterwards. And I mean, this stuff that we're about to do is on the final. It's like not important, but I recognize that we might be operating at half tanks. Okay, so, all right, so this is us. So what we're doing today is Newton's laws. And also, I assume that what I'm doing today is I'm about to start catching up to some stuff that has already started in the labs. I assume I'm just going to reality check with you for 1 second. The very, very last thing that you did in lab with Wu.
How to go on? You pick up the clothes.
So the very last thing you did in lab with Wu was what? Anybody? Scary. What's the last thing you did? Or the very next thing that's due in lab? Can I ask?
The next thing that's due is the Newton's law. Like,
oh, sorry.
went over it last night.
Very next thing that's due is the Newton's laws thing. Is that what you said?
Yeah, it's due next class for us.
It's due next class. Okay, and is that that's the slow down, fast up? That
I think I'm not really sure. He didn't really go over it. He kind of just told us that it was due, and it's a bunch of questions on Newton's law and all that stuff.
Oh, I'm sorry. Oh no, good. I'm glad I do know what you're talking. Oh, perfect then. Okay.
But the formal lab that we're doing is on like the pendulum, like the ballistic projectile, and horizontal and vertical velocity.
Great. Okay, perfect. That is totally helpful. That's perfect. That's what I was sort of hoping. Okay. That answers that's great. And then what I'm going to do here is hopefully helpful to those things. And you have lab on, oh, okay. Formal lab is done next class. Okay. Oh, this is perfect. Noon. Okay. The formal lab is due next class, and next class is what is tomorrow, right? Or like you, right? Due. Right. Thank you, Antonio. Totally. Thank you. Or Tuesday. Oh, great. Okay. So this might. So again, if you space out, if anybody like, so what we're about to do now is like the new lecture material, but it's meant, you always sort of see things first in lab because it's science. But what I'm going to do today, hopefully will sort of help you with both what's due on Tuesday and maybe even the thing that's due in 2 weeks. Hopefully it'll help you. What was I just going to say? Right. Hopefully it'll help you with that, I guess is what I'm trying to say. Something. Oh yeah, okay. And so here we. Okay. Well. Okay, the next chapter, the topic is these Newton's laws of motion. That's what we're about to get into now, but I want to segue there by reminding everybody that the underlying theme of this whole class and of really all of physics, as far as I'm concerned, is Galileo's principle of relativity. Like what I sort of promised you at the beginning when we did this whole train of thought thing, that is that there's the underlying principle that comes out of deciding that the Earth is moving. The underlying way that we justify that to ourselves, the underlying way that we explain how it could be that we could be standing on a floor that feels stationary to us, yet we could believe that it's going 65,000 miles an hour all the time past the sun, that the way that both of those could be true at the same time, that you feel nothing, yet you're moving at 65,000 miles an hour, is that what we decided was that the laws of physics are the same at all constant velocities. That's the principle, like that is the principle of Galileo, that the laws of physics are the same in all frames, in all unaccelerated frames of reference, or all unaccelerated coordinate systems, if you like. But I said then, and I'm going to continue to say, that that statement of English, which either might sometimes seem really obvious, like, yeah, of course the laws are the same. I mean, they're laws, right? Like, wouldn't the laws be the, or that statement of English that may seem really obvious, like, yeah, I know the earth moves. I've known that since third grade. Is that really that interesting? But at the same time, when you think about the statement enough, it also kind of seems like obvious that it shouldn't be true. Like, wait, what, you're saying the earth moves at 65,000 miles an hour, but I never ever feel it? Or you're saying that it's just as legitimate to say that the earth moves past the sun as to say that the sun moves past the earth? Like, you're saying astronomy could work either way, and we could predict eclipses the same way either way? Or you're saying that bombs should fall out of an airplane all in a vertical line, not in a diagonal? Like, I'm saying that every aspect of this principle, that the laws are the same in all velocities, that actually every next chapter of physics, every next equation, no matter how complicated or surprising physics ever get, it's always just an extension or an application or some new perspective on that principle. That's like the underlying lesson. And really, in order to do all the math of physics and all the details that seem hard, truly, it's never the computations or the mathematics that are actually what's hard. It's, as many of you often tell me, it's like knowing how to start a problem, which means knowing what concept to use, or knowing how strongly to believe in a certain concept that tells you how to set up the equations and all the math. The concept always in physics is this principle of relativity. It just takes many forms. What I'm saying in this, and I'm saying each next chapter or each next topic of physics is really just another form or application of this principle. So what we have in this class so far, so I just want to remind you where we are with the principle, and I'm going to use it to introduce us, or at least lecture-wise, to Newton and to Newton's laws. So let me remind you, I'm not going to rewrite it right now, but as far as the first exam was concerned, we already had 4 forms of this principle. We said form number 1 was the laws. Well, I'm not going to write them all again because it's going to take too much time, but you have them in your notes, but I'm just going to remind you, we thus far, and if you were to memorize anything or anything, like you may not remember right offhand right now, but hopefully they're in your notes and you should know. So I'm just going to say, we've established 4 forms of this principle. The first form is the original central idea that the laws of physics are the same in all constant velocities, or all unaccelerated reference frames, or all unaccelerated coordinate systems, however you want to say it. That's the first form. Then the second form, just to remind you, the second form was, oh, well, if that's true, then that means, like, the second form is no experiment can be performed or even designed to measure the absolute velocity of a single object, like through space. I.e., the second form said you cannot do an experiment to find out how fast something is going, period. Like if you're sitting in the airplane and like you just wake, or you're sitting in that high-speed train like in Tokyo or something, and you just wake up and you look out the window and you're like, oh my God, are we moving or not? Are we getting there, or are we parked? And then you look out the window and it's a very smooth train, or it's a very smooth airplane or whatever. And you look out the window and you see things going past the window, right? So you're like, oh, okay, there's motion. But then but say the things that you see are like clouds, if you were in an airplane, or the things you see are like white lights. If you were in a subway, if you're smart, you might then say to yourself, oh, wait, okay, I see stuff moving, but like, wait, how do I know whether the stuff is moving past me and I'm sitting still, or am I moving past the stuff and it's sitting still? Like, actually, how could I tell whether I'm really, like, I can tell that I'm moving past those things, but how can I tell if I'm actually moving or not? how can I do, like, how can I figure out if I'm actually having a speed of 0 or a speed of something else? You might consider doing some kind of experiment if you really want to be scientific about it. You might consider like dropping an object and seeing what it does, right? But the thing is, and I'm just reminding everybody again, I'm just trying to put perspective on this again. Remember, if you like wake up on a high-speed train, or you wake up in the middle of a smooth airplane ride, or an elevator, like in the Empire State Building or something, you could say to yourself, I want to be scientific and prove whether I'm actually moving or not. But if you do an experiment like drop a ball, the thing is, you know that if the airplane is parked, if it's like on the ground and you drop a ball, the ball is going to land at your feet. Like, you might not know all the details of gravity, but you know things fall straight down. So if you're parked, the ball would just fall straight down at your feet. So you might figure, okay, I'm going to drop a ball, and if it lands straight at my feet, that means I'm parked. But the fact is, the laws of physics are the same at all velocities. So, as you also know from experience, if you think this through, even if the plane is going at 500 miles an hour, constant velocity, past the clouds, past Japan, whatever, in that case, if you dropped a ball, it would still land directly at your feet. The laws, like form number 1 says, the laws are the same at all velocities. Therefore, any experiment that's done at any velocity will work out and yield the same results as it would at any other velocity. Like, I don't need to know the details of the experiment. I don't need to know how technologically advanced I am to know that whatever experiment I ever design to do, its result is going to be the same whether I'm moving or not. Like, that's why you're allowed to walk around in the cabin of an airplane, when it's cruising, when it's not accelerating, when it's going at a constant speed and constant direction. You're allowed to get up, walk to the bathroom, use the bathroom, come back, pour yourself a drink, complain about the movie, blah, blah. And you can jump up. And as we've said in the past, you could jump up and you don't worry that the back of the plane slams you in the butt, right? The laws are the same. That's form number 1. Therefore, form number 2 says, good luck doing an experiment to find out whether you're actually moving or not. You can always find out whether you're moving relative to something else, like look out the window. But what you're doing in and of yourself as a single object, you cannot determine that by any experiment ever, 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 says Galileo in form number 2, because of form number 1. So then form number 3, again, this is like technically review here, but again, if you really get this, if you both get why it's true, but you also get how in some cases it might be surprising, and if you really get that what I'm saying is always true, then you get the heart of physics, and all the rest of the math is really just detail on this. But I mean, it keeps developing, like to form number 3, where we say, oh, well, wait a minute, this is an experimental science. Like the whole thing of physics, like the birth of physics is the birth of the scientific method and reproducible experimental designs. So if in form number 2, we just realized that you could never ever do an experiment to measure or detect the velocity of a single object unto itself, or like how fast it's moving just like through the universe, if you can't do an experiment to figure that out, then as far as science is concerned, or as far as physics is concerned, then it's meaningless. Like if you can't do, so in other words, form number 3 says velocity can only be meaningfully measured as a relation between 2 objects. Velocity never means anything with respect to one single object. Velocity is a relation between 2 objects. It is not a property of one object. Like that's what we're saying in form 3. We're saying form 2, we're saying you can't do an experiment to measure single velocity. So form number 3 says, well, if you can't do an experiment, then it doesn't, like, then it's for either theologians or pure mathematicians or philosophers or drug users or whatever to talk about. As scientists, if we can't measure it in an experiment, then it's not meaningful to us. So form number 3 says velocity is always a relation between 2 objects, never a property of one object. And that's why we start always writing velocities with the subscripts like VAB or VBC, like you kind of did in the exam. Like from here on, right. That's why we start writing with subscripts. So then in form number 4, and I'm almost now caught up with where we are here, in form number 4, that's when we turn this idea into like a more mathematically useful one or a more symbolic one. And form number 4 is where I have those 3 cases and I say VAA triple equal sign 0, like the velocity of a single object relative to itself is always 0. VAB is always equal to negative VBA, like the velocity of me relative to you is just the opposite of the velocity of you relative to me. So if I'm going to the east, if you see me go to the east, then I see you go to the west at the same amount. And we're both seeing correctly. I mean, by seeing, I mean whatever measurements we would scientifically take, right? So you could say the Earth goes past the sun, or you could say the sun goes past the Earth, and they're both, assuming nobody's accelerating, they're both equally legitimate, equally correct, right? And then the third part of form 3 was that VAC equals VAB plus VBC, right? Yeah, meaning the velocity of me relative to the subway plus the velocity of the subway relative to the ground equals the velocity of me relative to the ground. That's why I take subways, like when there's no COVID. That was form, okay? And so we used all of those, whether you realized it or not, like that, all of those were underlying everything you did in the first exam. Now, we're going to go to form 5 and form 6 and form 7, like right now. We're going to keep pushing. I'm going to give you new material now, but the more you can see the new material as just an extension or an application of this old material, the more you really are doing physics correctly. So before I tell you anything about Newton's laws, this by interlude here, I mean, I'm going to give you GPR form number 5 now. Okay. I've said it sort of before, but I never called it that yet in this class. I'm about to give you the 5th form of GPR, which is going to say, again, is going to say something you kind of already know, and you kind of already used in half the problems on the exam, and you kind of already used in lab 3 and lab 4. In fact, this is very helpful for your write-up in lab 4. But I'm going to put it in words now and show you. So GPR, and again, GPR stands for Galileo's principle of relativity. Form number 5 is this. Okay, I think I may have said this once or twice before. Maybe I even wrote it down sort of casually, quickly, but it's a thing. It's a very big thing. I'm going to read it out loud in a second. I'm going to try to translate it, but let me tell you again, this concept is what is underlying lab 3 that you did a while ago with drawing the directions all over the piece of graph paper, whatever. And then lab 4, the thing that evidently you have a formal write-up to Tuesday. So this is really a thing to pay attention to for that. Oh, and so I'm going to read it out loud and explain it, but then one last thing also. Okay, this is a general principle, so it's true for any number of dimensions. So I'm saying n, like I'm making a statement here about how n-dimensional problems or experiments or phenomena work. So ultimately in the real world, we tend to think of it as having 3 dimensions of space. in 1 dimension of time. So ultimately, this is a statement that's most applicable to like 3-dimensional problems, but a lot of problems that we look at in physics, especially at first, are easily understood as 2-dimensional problems, like lab 4 is a 2-dimensional problem. Yeah, sorry, right. Lab 4 is a 2-dimensional problem. You like the gun fires, you've got stuff going in this direction, but you also have stuff but the bullet, whatever is shot out of the ballistic projectile, like it's going along a horizontal axis, but it's also moving along a vertical axis. Nothing particular is happening, especially if you do it right. Nothing is particularly happening left to right. We don't worry about the physics left to right. So that's all happening in a plane. It's a 2-dimensional problem, right? So is lab 3. You've got all these different directions. You're doing north. You've got north and south. You've also got east and west all over your graph paper. Also in your exam, like the Wile E. Coyote problem, in particular, was like a 2-dimensional problem. The Yaverbaum problem was very much like lab 4. These are all 2-dimensional problems. So it might be easiest to understand what I'm about to say if you just in your mind substitute 2 anytime I'm saying n here, right? But what I'm saying is true no matter how many dimensions you have. So what am I saying here? I'm saying that because the laws, like this all goes back to Form 1. Remember, the laws of physics are the same in every different reference frame, or in other words, in every different coordinate system. And the simplest possible coordinate system we know is one axis, right? Like a coordinate system, a 2-dimensional coordinate system has 2 axes, but a number line itself is one coordinate axis, and it constitutes its own very simple coordinate system. Hence our very first homework of the whole semester, the number line problem with the professor running back and forth. So if we really believe that the laws of physics hold and are true and are the same in every independent coordinate system we can imagine, then even in an XY plane, what we really believe is that physics is happening in the x-axis and physics is also happening in the y-axis. And if we have a 2-dimensional problem like lab 4, it looks like something is happening in 2 dimensions simultaneously, and something is, like a ball is going forward while at the same time it falls down. But the physics principle is that even though it looks like a ball going forward while it falls down, really what you have is you don't have a 2-dimensional problem. You have 2 separate 1-dimensional problems that are separate in the fact that they're in the sense that they're each following their own physics laws. Like gravity is doing its thing on the y-axis, and distance is equaling rate times time on the y-axis. And all your equations from the last exam, from the beginning of the semester, all those constant acceleration, 1-dimensional kinematics equations, they each continue to apply through all of physics. They will always apply to each dimension of space independently. Like that's why the word is independently at the bottom here. We're saying that when something appears to happen in 2 dimensions, really it's 2 1-dimensional things that are both happening independently, like not affecting each other. Like you can trust the equations to apply to the y-axis, and you shouldn't, and they won't get messed up by the fact that x-axis stuff is also happening. It's just that they're happening at the same time, simultaneously. So from here on in, I'm saying, again, this is just an extension of an old principle, but the way we solve all higher dimensional problems, and this is what in effect you were doing on the exam, like something looks like it's happening in 2 dimensions, but you just break it down and you look at, you analyze each dimension independently, but then you say at the end of the day, oh, they're occurring at the same time. Like the amount of time it takes the road runner to run across the road has to be the same time as the time it takes the box to fall on the road runner. Okay, so from here on, and this is a principle, and I'm anywhere you can think this through or mention it in your lab report on 4, it's only going to help you, I promise. In lab 4, you have in the x-axis, x equals vt. Well, really, let me say it even better. In the x-axis, you have x equals 1/2 at squared plus v naught t. In the y-axis, you have x equals 1/2 at squared plus v naught t. You have this physics problem with that equation and this problem with that equation. They're happening at the same time. T has to be the same for both. That's why, in fact, in lab 4, you solve for t first using the y-axis because you have more knowledge. because you know how gravity works in the y-axis and you know how high your lab table is. So you use the y-axis, you do y, I mean, I'm saying this fast, so I'm kind of assuming you already kind of know what I'm talking about, but the way it worked in lab 4 was you apply y equals 1/2 at squared plus v naught t to the y-axis, but you look at the y-axis and you say, aha, in the y-axis there is gravity, so A is 9.8. And by the way, there I would not round it to 10 because it is a lab and you're trying to get data and all that. So in the y-axis, A is 9.8 pointing down, but V naught in the y-axis, V naught initial velocity is 0. And I'm hoping this jives with what some of you are already thinking. In the y-axis, you do have acceleration of 9.8. You do not have initial velocity in the y-axis, because even though that ball like flew off the table, or whatever it was in simulation, even though that ball like zoomed off and was definitely shot, it was not just casually dropped, it was thrusted, but it wasn't thrusted in the y direction. It was neither thrust up nor was it thrust down. It was not shot at an angle, in other words. So in the y-axis, you have y equals 1/2 at squared plus 0. And you know what y is, it's the height of the table. You know what a is, it's 9.8 due to gravity. So you like rearrange and you solve for t in the y-axis. Like this is, again, hopefully what you, if this is new information, then if this is new information to any of you, then I think it really is helping you, because you need to know this to write up your report in lab 4. So you go to the y-axis and you solve for the time, doing table height equals 1/2 9.8 times t squared, and you multiply both sides by 2 and divide by y, and then you square root and you get a time. And then what you do is you say, aha, now I'm going to look at the x-axis and I'm going to look at the physics independently in the x-axis, but I'm going to use this time information that I just got from the y-axis, because even though both are independent physics things that are independently following their own physics laws, they are happening at the same time. So you solve for the time using the information you got in the y-axis, then you go to the x-axis, and in the x-axis, you again can say, okay, x equals 1/2 at squared plus b naught t. Only now in the x-axis, a is 0. There is no gravity in the x-axis. It is independent from the y-axis. So there's no speeding up or slowing down. There's no reason for the ball to speed up or slow down in the x-axis. But there is, so it's y equals 1/2 0 plus v naught t. But now in the x-axis, there is a v naught, like it was thrust off the table at some v that you got by using your photo gate, by dividing the diameter of the marble by the time through the photo gate or something like that. Like the details might be a little different now since you're doing simulation and all. But so you're doing literally the same equation, the same physics in both axes, but you're doing them independently, and what you're filling in is totally different. In the y-axis, you have acceleration, you don't have initial velocity. In the x-axis, you don't have acceleration, but you do have initial velocity. You take the time that you got from the y-axis and you plug it in to the equation for the x-axis, and what you end up basically writing is x equals v naught t. The v naught you got from the photo gate, the t you got from the y-axis, so you solve for x, and that's where you said the ball was going to land, or that's how far back you put the gun, or whatever the lab specifically asked you. But and this is just I know you've already done it, but this is the analysis. This is what you're trying to write up in your own words. Also, I'm saying this is the concept. The concept is two-dimensional physics really means two one-dimensional physics is always. And a three-dimensional physics problem is really three one-dimensional physics problems. By the way, this is also why and I know we only have 5 minutes more, it's okay. I mean, I apologize, but I will end on time. But this is also why we spend so much time on those few equations. Like, of course, there's a lot more physics to do. Of course, we have to get more and more realistic with our problems and get into 2-dimension and 3-dimension. Then we have to get into forces and all that. But the truth is, those equations are always, there aren't any more equations ever for the kinematics of any individual dimension. It's now just a matter, it's like we spent all this time basically solving one side of a Rubik's Cube. And now what we just need are techniques for how you get from one side to all the other sides. I mean, that's actually a horrible analogy. It's like not even right, but hopefully you sort of get my point. So GPR form number 5 is, okay, whatever we've now learned about one dimension is going to keep on applying. Even if we pile dimensions on themselves, we're just going to recognize that each dimension follows laws of physics independently, yet they can follow the laws at the same time. That's GPR form number 5. Now I know I only have 4 minutes. What now this brings us to, I'm going to sort of summarize very quickly and we'll pick up on this Monday. Like this all comes from Galileo. Galileo lives from 1583 or something to 1642, the year 1642. Galileo dies in 1642, and a few months later on Christmas Eve or on Christmas of 1642, Isaac Newton is born in England. Newton comes up with 3 laws of motion. With the only 4 minutes left, I'm not going to even pretend to explain them on that, but I'm going to write them very quickly so you have them. I mean, you've heard them probably in 7th grade or something like that, but I'm going to just write them so you have them. But I want to tell you right now is I'm going to write down the 3 laws of motion, and that's where we're going to stop. But I want you to know right now that what is called historically Newton's law number 1 is in fact GPR form number 6. And what's called Newton's law number 3 is also secretly GPR form number 7. I'll write that down, but I'm saying these laws, which sound out of nowhere when you learn them in 6th grade or 7th grade, they're just further extensions of this principle. And Newton knew it. I mean, he didn't plagiarize. It was on purpose. Newton is just taking the Galileo ball and running hard with it. So just with the 3 minutes left, again, I'm going to stop talking. I'm just going to write them so you have them, so you know where we are for Monday. Of course, they're in textbooks and stuff too, but also I prefer you write them in my words, at least for now. So we're just going to write quietly for 3 minutes and then we're good. So here we go. And so even if you've heard this before, please do write it down. I mean, if you have to go, you have to go, or you can copy this later from the video or whatever, but please do write it in these words. That's law number 1. How am I going to do this? I'm going to flip pages. I'll flip back in a second if you want. So law number 1 is unless acted on by a net external force, an object at rest stays at rest, and an object in motion stays in motion at the same speed in the same direction. That's law number 1. Again, I'll go back in a second if you want me to, sorry, but I just want to get these down so you see that, so you have them. Law number 2 is this. That is law number 2. It's very mathematical. And then law number 3. So again, I could flip back the page. I know you all have to go in a second. I could flip back the page in a second, but law number 2 is a pure math equation. It's the one we're going to use a ton, but it's just sum of like sigma F with a vector sign over it equals MA with a vector sign over it. F net equals MA. Law 3, which is actually GPR form number 7, is the one that you've heard before, like equal and opposite reactions, whatever, but but write it this way, please. Law 3 says if object A exerts a force on object B, then necessarily object B exerts a force on object A of same magnitude yet opposite direction. We'll explain all these next class, or I'll explain, but those are the 3 laws. Again, I can flip back if you want or what, I don't know. But law number 1 is unless acted on by a net external force, an object at rest will stay at rest and an object in motion will continue in motion in the same speed, in the same direction. That's law number 1. Some people call it the law of inertia. It really is just Galileo's principle if you really, really, really think about it. Law number 2 is F, the sum of all forces on an object equals the acceleration of that object times the mass of that object. Law 3, which is really GPR form number 7, it says if I push you, you push me back automatically, necessarily, with the exact same amount of force, but in the opposite direction. None of these directly tell you what a force is. That's what I have to tell you, but I will tell you on Monday. If you want me to flip back, let me know, or if you're good, or if you say goodbye. Oh, bye. Okay, thank you. Okay, bye. Bye. Thank you. Thank you. Have a good day. Congratulations again. Bye and bye. 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 And I'm going to cut out before I say all the goodbyes because the other people are coming in and get them confused. So goodbye. Thank you guys. Thank you. Bye. 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 Bye.